Dear students, let us again move into the intersections and see that what type of intersections can be there, what can be the various shapes of those intersections, and once we are done with that, then we are going into the details of the things or the elements which needs to be provided on that. We started with the add grade intersections and we tried to look at the various shapes which can be there for a 3-legged or a 4-legged systems. And within those, then we also talked about the channelizations and the flared systems which can be there and how they help us in improving upon the safety and the smooth movements of different type of maneuvers which are possible at any of the intersection. Now, in today's interaction, we are going to move forward and we will start with the add grade intersections and then we are going to shift to the grade separated intersections. Now, add grade intersections, we were discussing about the shapes. The one another type which can be there is a rotary intersection. A rotary intersection means there is a circle at the center and the traffic is moving around that particular circle. So, if the vehicle is coming from this direction, it has a flexibility to go in this form or it moves into this area and then goes out of the system, or still it can move in this area and can go out of the system here, or it can come back and take a U-turn and go out of the system in this case. Now, when all of these movements are happening, so it is coming out here and it is going here, so it means it is diverging or it is merging. The reason being that there is another traffic which is moving in this form. So, they are going to cross each other. So, there is a weaving area, there is a diverging area, there is a merging area on this intersection and that needs to be taken care of very clearly. So, if you look at the another photograph being given here, that is from a right hand driving system. So, the traffic, the vehicles which are coming, they are coming from this direction, hence this giveaway line is being given. The point here is that when you talk about the rotary intersections, then the more emphasis or the more priorities are given to those traffic which are already there in this circle. So, where those vehicles which are moving around, they have the priority of their movements, and the vehicle which is coming in, then they have the second priority for that. But at the same time, if there are pedestrians around, then the facilities for the pedestrians by way of a zebra crossing, by way of the gap in the median and the islands, and the island being provided for different type of fixtures to be placed like signs or illumination, lamps, etc. So, they are being done here. The another case can be that if you have more than 4 approaches, then it is a multi-lag intersection, and in this multi-lag intersection, then there are going to be lot many things, lot many type of maneuvers from all of different directions. And if no controls have been exercised on this is a totally uncontrolled system, then you will find that there is always a possibility of conflicting situations arising in this particular area, which is this open area of intersection. So, here in this case what you can see is that there is 1, 2, 3, 4, 5 and 6 approaches which are there, from which the traffic is getting in and out of this intersection, and then from each particular side you are going to have a through traffic, left turning traffic, right traffic. That means 3 type of maneuvers. So, 6 into 3, 18 such conditions which are arising, and we have to take control of that. So, the conflicts has to be taken care of by way of different manners. Now, let us look at the geometrics here. Now, in the case of geometrics, we can have, and we have already discussed it as a part of shapes too, is that we may have a plane sort of intersection. Say this is a plane 1, and in this plane 1 means nothing is being extra done. Only thing is that we have a carriageway here, and that is how that is being provided from all the 4 sides, and the traffic is freely moving in and out in this at this particular intersection. But there may be a possibility that there is a lot of turning traffic from a particular direction. Say the traffic which is from this has a lot of turning traffic. So, that is where the flare has been provided, and it has been separated out by way of the different such type of flush medians which are being provided in terms of the pavement markings, and the traffic, if that is going through, is straight. So, that can also be there, and there is a possibility that there is a right turning, and the right turning can also be provided separately to do that. But then if this is a type of a scenario we are talking about a one way road system. So, in this one way system only, no other traffic is coming from the other direction, but the traffic from this particular direction is getting separated out. Now, another thing which can be there, now say the further the type of movements are increasing and we have to take care of that. So, what we have to do is we have to go for a channelization and we have to look at what type of the various type of road furnitures needs to be provided there. So, what you see island here, this is another island and that is another island. There is a median being provided on this side. There is a gap in this median, so that the pedestrians can cross using the crossing facilities. There is also a gap in this median, and then the pedestrians comes to either of these, and but from here then they need to be shifted to the other side. So, there should have been a connectivity by way of which the pedestrians comes to the curb side. But at the same time, because the traffic is there, so for considering the traffic and the traffic which is coming from here, the give way markings and the signs have been placed here. There is a right turning lane 2 which is also being provided here, so that the traffic gets into in this form and the traffic here is taking a left turn. Let us look at few of such cases. So, here what you found is a continuous median is being provided, therefore, there is no possibility of a crossing traffic here, and that crossings could have been provided at some other location, but the traffic which is coming from say this direction at a speed v, which may be design speed, and if it is desiring to go out of the system, then this is going to take a turn in this form, and the speed here v dash, this is going to be quite less than as compared to the design speed v. And so as to segregate the two movements, that is, this is a left turning and this is again a left turning. So, here this one is an exit left and this is for entrance left. So, the traffic which comes from here goes this way and then finally merges into the main traffic. So, this is how the things can be done, but opposite to that, here the direct taper is being used. So, there is a parallel system being adopted at this side and a direct one on the other side. Okay. And the lens etc., we are not looking at that because those are the parts which we are going to talk further. So, this can be one such of a type design, depending on that there are side roads which are not having more of a crossing traffic and it comes on a main highway, and that is how we can control the things. Then this is by control. So, by control is like again there is no control. So, that is one case. The priority control and the signalization, these are the other things which may be there. So, priority control and all those we have discussed previously too. Let us look at again in all of those cases. So, this is no control condition. Now, when there is a no control condition, it means all of the vehicles are allowed to move in and out of this intersection area as per their desires and wills as directions. So, this culminates into different crossing movements, different merging diverging conditions, and because of that lot many conflict situations may arise. And these situations, depending on if the traffic is not too high, that means the volume is not too much, then it may be okay, but if it is quite high, then that is going to create a problem. So, what you can see in these photographs too, that the traffic which is coming from this one is taking a turn. So, there is a conflict point here because of the turning and one through movement. Here there are two through movements, and again there is going to be a conflict point at this way. So, these are the things which needs to be taken care of, and if they are being taken care of, then it is going to change from an uncontrolled to a type controlled system. Okay. So, let us look at the another situation in terms of the what type of various conflicts which can be there if we are not exercising the control. So, here in the first case where you have a four-legged system, or the two roads are crossing each other and probably those two roads are of the same specifications, then it culminates into 32 conflicts. And these 32 conflicts, like if we are talking here that this vehicle goes in this direction and there is a vehicle coming from here. So, there is a conflict at this point. So, in that sense there are 4 through traffic conflicts, that means this is a through traffic conflict. 4 right turning conflicts, so where the traffic is taking a right turn, so it is going to have conflicts. 8 right turning with the through traffic conflicts, 4 merging, 4 diverging conditions, and 8 with respect to the pedestrians. So, likewise there can be say 32 conflicts which may be there on this type of a situation. Similarly, if you look at a T junction, so in the case of T junctions again different type of conflicts are going to be there, and they may be like 9 conflicts, it may be less, it may be more. Again, if you control the things, depends on it. This is a case where you have a rotary intersection, and in those rotary intersection the traffic which is getting in or getting out, or it is going this way or this is going out. So, on the basis of that again lot many conflicts can be there, and these shows that there are possibilities that 24 conflicts may be there which are equally divided as diverging, merging and crossing. So, if we try to omit those things, then we go into a priority system, and when we go into a priority system, then we are trying to give a priority of one type of a maneuver over the other one. Say if you see here, then the traffic which is coming from this direction, there is a stop line being provided here. So, the vehicles are going to stop, and if this vehicle has already started movement, then they will take a movement afterwards. So, it can also be assisted with the signals being provided at this one, but they may or may not be there. If they are not there, then in that sense we can also have the road signs. Say if you look at here, there is no signal, but a road sign is being provided which says a stop at this one, and then there is a vehicle which is going straight like this. But one thing which you could have observed is that in this particular diagram, in all of the 4 approaches from where the traffic is coming into an intersection, there is a stop line, but in this case there is a stop line only on 2 sides, and the rest of the 2 sides they are not having any stop line. So, it is a two-way controlled, or it is a all-way controlled system being provided, and the reason is that this can be a minor road where this one is a major road. So, the traffic on the major road is allowed to move at its speed, where the traffic which is coming from the minor road has to get the opportunity to cross or to get merged into it. Now, when you go into the further such type of things, then what you can have is again a channelization pavement marking system which provides exclusive movements for exclusive type of users, and that is what is being shown in this particular photograph. Now, the culmination in terms of the time segregations is coming from a signalization at any intersection, and this can provide, this can be an highest type of safe design, where based on the cycle lengths and based on the number of phases which are being adopted for the different type of movements at this intersection, we can reduce or we can eliminate the conflict points. Say if we allow the traffic which is coming from this direction, and it say that at one point of a time it is going straight, and this traffic is going straight like this, and along with this the left turning here and the left turning here is being allowed. So, now there is no such conflict, no traffic is crossing each other. So, this can be one way of doing it. Now, the other way is that now once the one type of maneuver which is being left from here is that now there is a right turning traffic. So, this right turning traffic is being allowed here, and this right turning is being allowed here. Again, now there is no such problem where the traffic is crossing each other, and there may be a possibility of any hazardous situation arising. So, what we need to look at is the number of phases which can be there, and by way of doing that, so it can be 2-phase system, 4-phase system, 3-phase system, whatever it is, based on that we can reduce the number of conflict points by signalization. So, here there is again a case where even the various types of priorities have been set. Say that this green color is for bicycle. So, the priority is coming to a bicyclist, and those bicyclists can come and stand in front of the vehicles. So, these vehicles which are stopping in this area, actually they can be challaned for it. So, that is the penalization which can be there. You can see again the chevrons being marked, the give way markings are there. Okay, so, the arrows which are specifying the directions in which the traffic can move, and the various types of channelizations which are there, which segregate say the through traffic and the turning traffic. So, all of those things have been done perfectly, and again in this type, or you have a flaring also in this side, because there is a lot of traffic which probably is going in the through direction or the straight direction, as well as there is a right turning traffic and the left turning traffic. So, they have been done perfectly. Now, let us come to grid separated intersections. Now, in the case of grid separated intersections, from the grid itself it says that the level difference is going to be there. Now, when there is a level difference, it means the more structures needs to be constructed. So, there is a one road going at a ground level, but there is another road which is going from the top of it. That means there is this structure coming in, and this is going to create more cost in this type of a structure. So, grid separated intersections are going to be of course costlier as compared to the add grade intersections, but then when you start segregating in this form, that becomes the highest form an intersection treatment. And because of this, there are always the possibilities, again depending on how many grid separations have been done, how many maneuvers have been separated out by way of level differences, it may culminate into the least of the delay or the least of the hazard to the crossing traffic. Now, this separation which we are talking here, this separation can happen in different forms. Say one road is going at this level and the another road which is crossing is coming from the other direction, and that is going either from the bottom of it or from the top of it. Depending on that, there can be an underpass or there can be an overbridge, or what we can also see as a say flyovers can also be there. So, this can be the way that separations can be created. Now, when we look at these separations, there are two ways of doing it. One is there are no ramps, another one is with ramps. Now, with ramps, if we are doing it, they are also being defined as interchanges, and this is the highest quality which can be there. So, highest level of flow provisions which are going to be there, they are going into the in the form of interchanges. So, here you can see that two photographs have been shown. Let us talk first of all here. So, what you found is that there is a traffic moving in this direction at the top, and there is a crossroad, and this crossroad traffic is going at the bottom of it. But then we are not providing any such conditions that there is this type of a road which is coming from the side and meets on the top road at some distance away, and that may be at grade intersection of course, but then this type of a separation, if it is being done, so can also be considered as say without ramps. But if you look at the case 2, now in the case 2 what you can see is that there is a traffic say which is coming from this direction, it is going below this particular traffic, and this traffic is going below this one. So, okay, so there is a different levels, and then this traffic is also having another level. So, this traffic is also moving on this as well as on this. So, if you come towards such area, what you find is there are multiple levels. Now, when you have these multiple levels, obviously the cost of the intersection is increasing a lot, but the beauty of this type of design is that each and every maneuver that is being provided with a separate arrangement, and therefore, there is no restriction to the flows. So, it becomes unrestricted flow conditions for each and every maneuver from each and every direction, and that is the best type of interchange which can be there. But yes, it requires lot of space, it requires lot of money to construct, and cannot be done in each and every location, and that is why you will find that there are not many across the countries. So, let us talk about something about those grid separated intersections which are not having the ramps. So, as I said, because they are not having ramps, they are only a single one solution where the two roads crosses each other at different levels. So, that is relatively cheaper as compared to interchange, but obviously costly with respect to the add grade conditions. The crossing traffic is segregated at two levels, or it may be at more levels, and that is done because you have a moderate to high traffic which needs to be controlled from different directions which are on the roads which are crossing each other. And segregation cannot be provided by an interchange due a cost consideration. So, that is a reason that we have not gone into that sort of a multiple level systems, and these may be under bridges, over bridges, flyovers. All type of movements are accomplished at surface level through parallel service roads or the slip lanes. So, here what you can see is that in this case again there are two levels, one level is here and another level is at this one. The two roads are crossing each other at different levels, and there are no ramps by way of which you can get into this or you are going into this particular system. Okay, so, that has to be done at some other distance away from this intersection location. Here what we found is that the traffic which is coming from this direction is going in. So, that is an underpass here, this is an overbridge being provided. So, for some type of movements, the movements are happening at the ground level. For some crossing movements which are there, those crossing movements have been done at different levels. So, it is a combination that some things happening at grade, some things happening at a grade separated, and that is why the total maneuvers are being taken care of. Again, let us look at some of the examples here. So, this is a case where a multi-lane highway is being provided, and this multi-lane highway is passing over a road which is say any sort of minor road, and the traffic is going to move on this particular road too. So, we have the movements here which needs to be taken care of. So, what is happening is that this highway is going at the top, and at the bottom of it there is an underpass, and at this underpass a carriageway has been provided, and the width of this carriageway is being capped on the basis of the amount of traffic which is going to be there. So, that is being done, and along with that the pedestrian facility is provided, because the people can cross from here, then they go, and this is how they can be moving out or in of this particular system. There is a service road here being provided at the side of this elevated system, and this service road can also be a slip road, because this traffic keeps moving in. So, the traffic slips into it and then goes out or this way, whatever are the requirements. But this design is, what you can see is that this is a sort of a 90-degree movement. So, any traffic which is coming from this direction or the traffic getting like this way needs to steer the vehicle a lot. So, this is suitable for light vehicular underpasses where not many heavy vehicles are there. So, this type of changes needs to be done based on the type of the traffic or the amount of the traffic which is going to be there. Say in this case, if we have to look at the trucks and buses, then the turning radius is an issue, and therefore, this has been eased out here. The corner radius has been provided more as compared to the previous one, as you can see in this diagram. So, that sort of a change is being done, and this may or may not change. The width is going to change as per the requirements, but what type of measures which needs to be taken for the control of the maneuvers in and out of the road are being taken, whether in terms of a stop line or in terms of a giveways. So, these are things needs we have to make sure that they are being provided. So, here that what you find is the traffic is increasing, and in this traffic then we are trying to have either the priority systems or the systems by where the signals are controlling the traffic, but there is a median which is provided in the center like this, which is segregating the two directional traffic. So, the traffic which is coming here is going in this way, or this is traffic which is coming. If there is a two lane system, then there is a possibility that traffic can come from this side and get into it, depending on that there is a development and this traffic gets into this slip lane. Okay. So, now we have a more wider system, because this road is actually also a major road and it is also having a good amount of traffic. So, we have gone into this design. Again, there is another design where again you have to control a lot of traffic, and if you are controlling this lot of traffic, then this can be done by way of a rotary or a roundabout. So, what you found is a lot many space has been given. So, this is the carriageway which is circling the circle, being provided as an island in the center. For the pedestrians, then the straight path has been provided here, and this is again an island being provided, and there is an abutment at this point and abutment at this point for the elevated structure which is being provided at this location for the crossing traffics. Here further type of say channelizations has been utilized so as to allow the different maneuvers. Say one maneuver which is being allowed here is this U turning here, then there is a straight movement, then there is a left turning, there is also a service road separately by way of a median, this is being separated out, and then for pedestrians the movements are there. Similarly, there is a median here, and then the directional traffic is being taken care of. So, this is for high traffic conditions where lot many maneuvers are there, maybe this type of a design can be adopted. So, now let us look at the interchanges which are being provided with ramps. As you can see in this photograph, lot many directional movements are being provided, and they are exclusive directional movements without having any interference with any other movement, and that is where the flow becomes uninterrupted and keeps going. But then the amount of area which it is going to occupy is enormous, and the cost which is involved in providing these type of interchanges is also quite high. So, these grade separated intersections with ramps, if we are talking, they are provided where the access control is needed, and when this access control is being provided, then it means no such type of cross movements or the conflict movements are there. The crossing traffic is heavy and other intersections fails to handle it, or they leads in excessive delays or in crashes, then also we should go for these interchanges. But when we provide these interchanges, depending on what type of high speed facility is being provided, they cannot be very near to each other. They have to be provided at certain spacings, and that is what is being defined here, that desirably it should be 20 to 30 kilometers if we are looking at an expressway. An absolute minimum condition is 3 kilometers, which may be there in some cases. Now, when we look at these interchanges, then these interchanges can be of two types. One is service interchange, another one is system interchange. Let us look at the service interchange now. Now, the service interchange are being defined as those interchanges which does not maintain free flow through all its elements. Now, when we say that the free flow is not being maintained through all its elements, it means obviously there is a major road and there is a minor road, a category road, upper category road and a lower category of road, and they are crossing each other at this particular location. And when we talk about this lower category of road, then basically it can be anything like highway, arterial, subarterial, but this particular road is having add grade intersections, and that is why this is being defined as a lower category of road, whereas other category, wherever it crosses, every location it is going to be a grade separation with respect to the other crossing route. So, that is why this type of an interchange is being defined as a service interchange. The examples can be like Trumpet or T-type interchanges, etc., and they are suitable for three-way junctions with no weaving, limited requirements of ROW is there, right of way, and the single point toll plaza is another thing which can be provided when we are looking at these T types of Trumpet type of designs. So, you can see here the designs being shown. So, this is a Trumpet type of design where the movements which are going to be there. So, this movement is coming from here, there is a left turning allowed, and there is a straight movement is going on in this form. So, this is how it is being taken care of, and whereas if the traffic is coming from here, then it goes in this direction, or it can go in a straight form also. So, thus the through traffic as well as the turning is being taken care of. So, the only thing is that at this point, say here or at this point, there is a grade separation, but this one is at grade. So, this is at grade, but this one is grade separation. Okay. Similarly, this is a T type of situation where this grade separations have been provided at different locations, and that means we are trying to provide a very good interchange where no such crossovers are there, but then this location or these locations, they are again at grade conditions, and this can be another type design in the case of T type of a service interchange. As you can see here, this is a trumpet and there are two trumpets being provided. So, there is a one main highway here and there is another main highway here. This is Tirupati and Tiruttanan and Chittoor and Tachur area. So, these two are being connected. So, instead of providing a connectivity at this point, the connectivities have been done a bit away from this crossing location, and that has resulted in a double trumpet. So, this is double trumpet. So, the traffic which is coming from here, that goes and then gets into in this form, or there is a traffic which is coming from here, goes in this direction, there is a traffic which comes in this direction, there is a traffic which goes into this direction, and the traffic is also going straight either of the directions. So, likewise all type of movements have been provided when we are looking at this design. So, we stop here and we will be continuing with our other type of type designs, in this case also of grade separated, and that is what we will be taking up. Till then, thank you and goodbye.